The student did another investigation. This is the method they used. They put the amylase solution and starch suspension into a boiling tube. They kept the pH at 7.25. They put the boiling tube into a water bath at 25 degrees C. They measured the amount of sugar produced every 30 seconds. So, calculate the mean rate of sugar produced per minute during the first 5 minutes. So, first 5 minutes. So what I would do with this graph is I'd go, okay, up to 5 minutes. First 5 minutes, I'd hit the line, so I'd actually do an extrapolation line and I'd come across to look at how much sugar was actually produced in that first 5 minutes. Okay, now I'd roughly estimate from my extrapolation line, and do draw them on, that there's 2.7 units produced there. Now we're doing it per minute. So if there's 2.7 in 5, I could just do 2.7 divided by 5 to get 0.54. Now if you got the right answer and didn't put that there, you get 1 mark. So please put your working down. Iodine solution is added to a sample taken from the boiling tube after 10 minutes and after 60 minutes. So after 10 minutes, we can see that there is still some sugar being produced. So that must mean there's still some starch there. So because of that, I suggest the solution goes black. Okay, remember, if there's starch present, iodine will go black. If we look after 30 minutes, there's not much sugar still being produced. Okay, so I would suggest that because of that, it's mostly sugar, so it does not go back, or it stays the same, it doesn't really change. So that's brown, isn't it? Yeah? The scientist repeated the investigation at 37, so that's a higher temperature, ladies. Draw a line. Now look, 2 marks. So you get 1 mark. Remember, temperature will speed up enzyme action, and to represent that on a graph, you need a bigger gradient, a greater steepness here. Okay, so I've got a nice steep curve for 1. But remember, it will plateau at the same point because there's only an indefinite amount of starch. So you've got to put that line level once that starch has stopped being breakdown down, because there's not enough left. It's just going to plateau there. But the difference is it will happen more quickly. So that's your second mark. Okay, question 9. In 2014, there was an outbreak of Ebola in Africa. At the time of the outbreak, there were no drugs, no vaccines. By March 2015, there were estimated 9,850 deaths due to Ebola. The number of deaths is an estimate. Suggest why it's an estimate. Well, in Africa, you probably wouldn't record all of the deaths because perhaps they weren't happening in places near a hospital and recorded that way. And perhaps not all causes of deaths recorded. So perhaps someone died, but they didn't know why they died, and perhaps it was because of Ebola. Why were there no antibiotics to treat EVD? Remember, antibiotics are not used as they do not kill viruses. They kill bacteria only, antibiotics. After the outbreak began, drug companies started to develop drugs and vaccines. And they started to test and trial them to increase the number of new drugs. Draw a line from each word about drug testing to the definition of the word. So the dose is the concentration. The efficacy, that one you may have struggled with, is whether a drug works to treat the illness. So is it efficient? That's how I remember that. Toxic is to do with, does it have any side effects? The results of the drug testing and the drug trials are studied in detail by other scientists. Only then can the results be published by the drug company. Suggests one reason why the results are studied by other scientists. You need to prevent false claims. There's a lot of money in making drugs. So people might have just gone, oh yeah, this is the best drug. But you have to make sure that they're not doing that. You need to avoid the bias. So, this is my drug, it's the better one. So you need lots of different opinions. And therefore make sure the claims are correct. So you would have got a point for either of those things. Okay,